Hello everyone, welcome back. So we have already completed the order responses. First topic was what? Order and responses. Next topic we have completed first order RC circuits, concepts and different types of problems. And then after we have completed concepts of RL circuit, and in the next we have completed the problems based on the first order RL circuit. And today we are starting the most important topic, that is known as the problems, especially problems based on what? T is equal to 0 plus instant. Okay, so there is no theory in this. You just uh, follow these 3 steps. You will definitely get all the answers related to the problems based on the T is equal to 0 plus conditions. Okay, so step 1 is what? Evaluate all the initial conditions, that is at T is equal to 0 minus. Okay, IL 0 minus and VC 0 minus, and we know how to calculate IL 0 minus and VC 0 minus. While calculating IL 0 minus, what will happen? Inductor will be shorted. Okay, while calculating the VC 0 minus, capacitor will be what? Short circuited. Is it okay? Now this step 2 is what? That is IL0 minus will be same as IL0 plus and VC0 minus will be same as VC0 plus. Why? The above condition is always true. The above condition is always true to satisfy the energy conservation principle and to avoid the generation of impulse signal. Just remember this thing. I will explain this at the end of the transient. Okay, at the end of the transient, how you have to, how this is getting equal. Okay, we will take one problem on that and we will discuss why this is happening. IL0 minus, why this IL0 minus is exactly equal to IL0 plus. If you do not follow this, then what will happen? The energy conservation principle will not satisfy. Whatever the energy you will get at T is equal to 0 plus, that will be infinite, and in a practical system that is not a feasible thing that you can get a energy infinite. Can you get the value of energy infinite? No, that's not possible. So it is impractical thing. That's why we are saying IL0 minus is always equal to IL0 plus, but and VC0 minus is exactly equal to VC0 plus condition. Now the step 3 is what? What is the step 3? Draw the network at T is equal to 0 plus instant. Okay, by making L as open circuited and C is at what? Short circuited. Okay, at T is equal to 0 minus, L behaves like a short circuit, but at T is equal to 0 plus, it is behaving like a open circuited. At T is equal to 0 minus, C is behaving like open circuited, but at T is equal to 0 plus, it is behaving like a short circuit. Okay, please remember this point. This is very important. L behave like open circuit, T is equal to 0 plus. C will behave like a short circuit, but T is equal to 0 minus. This was open and this was for short circuit. Okay, now the including the initial conditions, the time domain model of the inductor for T greater than 0, we have already done this one. There is a current source, there is L. Okay, now if you want to draw the equivalent model at T is equal to 0 plus, what will happen? This will be what? Open circuited. So I have just make it open circuit. Okay, similarly for a capacitor, the time domain model for T greater than 0, we have already done this thing. This is the initial voltage source, this one is C, this is the total voltage across the capacitor. Okay, if you want to find the equivalent model for C for T is equal to exactly 0 plus condition, what will happen? This capacitor will be what? Short circuit. This is the equivalent model of capacitor at T is equal to 0 plus. This is the equivalent model of what? Inductor at T is equal to 0 plus. Now the last step is what? Write the desired equations using KVL and KCL, mesh, nodal, whatever analysis you want to do, you just do it and find the response of your interest. Okay, so first is what? Evaluate the initial conditions at T is equal to 0 minus, as you were doing in case of RL or RC circuit. Then what? IL0 minus will be always equal to IL0 plus, and VC0 minus will always equal to what? That is equal to VC0 plus. Then draw the circuit at T is equal to 0 plus condition. By L must be open circuited and C must be what? Short circuited, and draw the equivalent. Replace L with this circuit, replace C with this circuit, and then finally apply the nodal, mesh, KVL, KCL. You will get your response at T is equal to what? 0 plus condition. Okay, So moving to first problem in this section. What is this problem? It is asking about, in the circuit shown, find the values of I0 plus and rate of change of current I20 plus in the given circuit. So what we will do in the same manner. Step 1 is what? At t is equal to 0 minus, L behavior is what? Short circuit. C behavior was open circuit for t 0 minus. Okay, so we will calculate first Vc 0 minus and I2 0 minus. If you do so, switching action what? At t is equal to 0 minus, switch is what? Open. If switch is open, capacitor will be open circuited, inductor will be short circuited. If you do perform the analysis, what is happening? This is open circuit, there will be no current. Is it okay? There is no current here also. Why? This is open circuit. That means this voltage will be exactly same as how much? This is 10 volt. Is it okay? Similarly, this current is how much? There is no path is here. That means this current will be how much? That is equal to 0 ampere. So I2 0 minus, or you can say that this is the inductor current. Okay, so IL 0 minus, I2 0 minus, that is equal to 0 ampere. VC 0 minus, you have got 10 volt. And we know that Vc 0 plus and Vc 0 minus will be same, so that is equal to 10 volt. And I2 0 plus or I2 0 minus, or you can say IL 0 minus and IL 0 plus will be same as, that is equal to 0 ampere. What is the next step? Draw the circuit at t is equal to how much? 0 plus condition. At t is equal to 0 plus condition, what you will do? The switch is what? Closed. Switch is closed. This is 1 ohm resistance. Next is what? This is 2 ohm resistance. This is 2 ohm resistance. Now this capacitor, what was that here? That is capacitor. Capacitor will be replaced by what? A voltage source in series with capacitor, and capacitor will be what? Short circuited. Na? At t is equal to 0 plus, I have told that what is the equivalent model at t is equal to 0 plus? Capacitor will be removed with what? A voltage source only, because C will be what? Short circuited. So this will be removed with what? A voltage source, that is plus minus how much value? 10 volt. Okay, similarly the inductor, what will? Inductor means there is a current source, then there is an inductor, but inductor will be open circuited at what? At t is equal to 0 plus. So it has been removed with the current source whose value is how much? 0 ampere. That we can say, if a current source having 0 value, that means we can say that this is also open. Okay, so what is the value of I2 0 plus? This current how much? This is open, na? This is 0 ampere, this is open circuit. This I2 0 plus will be 0, and you are getting the here also 0 ampere. Okay, similarly I'm interested in finding I0 plus. So if this current is 0, I0 plus will be how much? 5 minus 10 divided by what? 1 plus 2, that is equal to 5 minus 10 divided by 3, that is equal to how much? Minus 5 by 3 ampere. Is it okay? This is the I0 plus value. Now it is asking about the rate of change of current I20 plus. You can see whenever the rate of change of current is asking, you can get the rate of what is this current I20 plus. This is the current that was flowing in the inductor, that was flowing in this inductor. If a some amount of current is flowing in the inductor, we can say that VL is equal to what? LdI by dt. If current is known in the inductor, you can find the voltage VL is equal to LdI by dt. You can see here, this voltage is how much? What is this voltage? This is inductor representation. That means this voltage is how much? VL 0 plus. Inductor voltage at t is equal to 0 plus. So we can write that VL 0 plus will be equal to L into D. Current is what? That is I2 0 plus. D I2 0 plus divided by T. Is it okay? So VL 0 plus will be how much? L into di2 divided by what? Dt. So VL 0 plus will be L di2 0 plus divided by dt. So di2 0 plus by dt is equal to VL 0 plus divided what? L. But we don't know about the value of VL 0 plus. You see here, this voltage is how much? This is VL 0 plus. Okay, This is 10 volt. This current, you know how much this current will be, same as I0 plus. Okay, this current will flow in this also because this current is 0. So you can apply KVL here and you can get the value of VL0 plus. Apply the KVL here, what you will get, minus 2 plus 10, minus 2 plus 2 into I0 plus, 2 into I0 plus, minus VL0 plus, minus what, 10 volt, that is equal to 0. So VL0 plus you will get 2 into I0 plus, 2 into I0 plus, 2 into I0 plus, you know, minus 5 by 3, you can get minus 10 by 3. So VL0 plus, you can also write it L di2 by dt. So di2 by dt is equal to VL by L, and VL is equal to minus 10 by 3 divided by L, and L value is how much, that is equal to 1. So answer will be minus 10 by what, minus 10 by what, 3 ampere per second. So the I0 plus value will be how much, minus 5 by 3 ampere, and rate of change of I2 plus current, that is equal to minus 10 by 3. So you have to follow the steps, definitely you are going to get the answers. So the next problem is what is the next problem? That is, it is given that this is the next problem. In the figure shown, the switch was closed for a long time before opening at t is equal to 0. The voltage Vx at t is equal to 0 plus will be. Okay, we have to calculate this Vx. This Vx is exactly same as what, the voltage across the inductor. Okay, this problem is based on t is equal to 0 plus condition, so we will follow all the concepts we have done in t is equal to 0 plus condition. So step 1 is what, find the values of initial value, that is at t is equal to 0 minus, L will be what, shorted, capacitor will be what, open circuited. Okay, draw the circuit at t is equal to 0 minus, switch is brought, that is closed. So I have drawn the circuit for t is equal to 0 minus. This will circuit look like this one. Okay, can you find this IL0 minus? Can you find this value? Okay, you see this short and this is 20 ohm. This will make it short, that means this current will be 0. Okay, so circuit will look like this one. Is it okay? So 2.5 ampere, this is current source, there is resistance 20 ohm, there is a shorted path around this. You can say that this total current will flow in this direction, there will be no current here. So what will happen, IL0 minus will be how much, that is equal to 2.5 ampere. This is shorted, this one is shorted. If this one is shorted, there will be no current here. So just remove this one like this, you can see. Okay, so IL0 minus will be how much, that is equal to 2.5 ampere. Okay, now next step is what, draw the circuit at t is equal to 0 plus condition. L will be what, open circuited, C will be what, short circuited. Okay, switch is what, switch is getting open. So I am drawing the circuit at t is equal to 0 plus, this is open circuited. Okay, inductor is replaced with what, the current source, and there is the L here, and L will be what, open circuited. You can see this value will be how much, the previous value, 2.5 value. Is it okay? This will be VL0 plus, and this will be what, Vx0 plus, that is equal to shown here. Okay, now from the circuit it is clear that Vx0 plus is exactly equal to what, VL0 plus. Is it okay? And we can get the value of what, VL0 plus. How much value it will be? Just make some simplified combination. What you will get? You can see here, this is open circuit. There will be no current here. 0 ampere. This is 0 ampere. This is 2.5 ampere flowing here. This is 2.5 ampere. This is 0 ampere. That means we can say that this 2.5 ampere is going what? This is also 2.5 ampere. You can apply here. No? You apply just a KCL. What you will get? 2.5 ampere you will get here. Okay. And if this current is flowing in this direction, what is happening? It will create positive here and it will create minus here. Okay. So what will happen? This will be positive, this will be negative. Okay. So voltage drop across this 20 ohm, how much will it be? 25 multiplied by 20, and this voltage will represent positive here and minus here. because resistance is an energy absorbing element. So Vx0 plus, this polarity is plus here, minus here, this is plus here, minus here. So we can say that Vx is equal to minus of 2.5 into what? 20 minus of 2.5 into 20, that is equal to how? Vx0 plus value, that is equal to minus 50 volt. Hence option C is what? Correct. Okay. Now the next problem is what? In the circuit shown in figure, it is in the steady state when the switch is closed at t is equal to 0. Assuming that inductance is ideal, the current through the inductor at t is equal to 0 plus will be, the current flowing through the inductor at t is equal to 0 plus will be, you see, step 1, at t is equal to 0 minus, at t is equal to 0 minus, this switch is what? Open. This switch is open. L behaves like a short circuit. Okay, so IL0 minus will be how much? 10 divided by what? 10. That is equal to how much? 1 ampere. Okay, and IL0 minus will be same as what? IL0 plus. That is equal to how much? 1 ampere. Is it okay? You can see here. You can see here. At t is equal to 0 minus, L will be shorted, C is open circuited, IL0 minus will be how much? 1 ampere. And we know that IL0 plus will be same as what? 1 ampere. Is it okay? Now drawing the circuit t is equal to 0 plus, L will be what? Open circuited, C will be what? Short circuited. This inductance will be replaced with what? A current source, and this is L has been open circuited, so this will be VL0 plus, this will be 1 ampere. You can see here this current will be how much? 1 ampere. Is it okay? So it is asking about this current, na? Inductor current. It is asking about inductor current. So at t is equal to 0 minus and t is equal to 0 plus, inductor current will remain always same. At t is equal to 0 minus, switch is open. If this is open, this current is what? 10 divided by 10, that is 1 ampere. So at t is equal to 0 plus, that current will also remain at what? 1 ampere. Is it okay? So that will be how much? 1 ampere. Now the next question is what? A coil of inductance 10 Henry and resistance 40 ohm is connected as shown in figure. 10 Henry and 40 ohm is connected in figure. After switch S has been in contact with point 1 for a very long time, it is moved to point 2 at t is equal to 0. If at t is equal to 0 plus, voltage across the coil, voltage across this coil is how much? That is 120 volt. The value of resistance R will be. Okay, so again the problem is what? At t is equal to 0 plus condition. Okay, so we will do step by step. Okay, so finally first step what? At t is equal to 0 minus, L will be short circuited, C will be open circuited. So I have drawn the circuit at t is equal to 0 minus. What you will get? Switch is at one position, switch is at one position. This is 120 volt, this is this one. Inductor will be shorted, inductor will be shorted. Okay, this is 40, this is R. So IL0 minus will be how much? 120 divided by 20 plus 40, that is equal to 2 ampere. So IL0 minus is always same as IL0 plus, that is equal to also 2 ampere. Now step 2 is what? Draw the circuit at t is equal to 0 plus, and inductor will be replaced by what? A current source, and inductance value will be what? Open circuited. So I have drawn the circuit for what? At t is equal to 0 plus condition, switch is what? Is moved to at position 2. So I have drawn the circuit. The circuit will look like this one. Okay, is it okay? L will be open circuited, C will be short circuited. That means this is replaced with the current source only. This is VL0 plus and this is 2 ampere. It is given that the coil voltage is how much? That is equal to 120 volt. Polarity here is not mentioned. I am taking it positive and taking it what? Negative value. Okay, so coil voltage under this condition at t is equal to, this condition has been mentioned to us. Okay, so writing the KVL in the loop shown, what will happen? This is VAB voltage, this is minus, this is plus. What will happen? This current is 2 ampere. This will flow in 40 ohm also. This will flow in R. Why? Because this is open circuited. Okay. So writing KVL here, what we will get? 2 into R. This will be positive. This will be minus. So 2 into R minus. This will be positive. This will be negative, because all resistances are always a what? Energy absorbing element. 2 into 2, 20, that is equal to 2 minus this one, minus to plus, it is getting voltage rise, that is equal to VAB. So 2R is equal to minus 40 plus 120, that is R is equal to 80 by 2, that is equal to 40 ohm. So what is the value of R in this condition? That is equal to 40 ohm. Okay. So moving to next problem. What is the next problem? The problem is saying that in the given circuit shown, the switch is kept closed for a long time and then opened at t is equal to 0. The value of the current I, where is the I? This is I. Just before opening the switch, t is equal to 0 minus, it is asking about, and just after opening the switch, that is t is equal to 0 plus R respectively, it is asking about the I current. Okay. So it's a very simple one. Okay, first one, it is asking about t is equal to 0 minus. So step 1, at t is equal to 0 minus, L will be short circuited, C will be what? Open circuited. Just draw the circuit. At t is equal to 0 minus, what is the switching condition? Switch is what? Closed. Switch is closed, L is shorted. Okay, so what we have to calculate? This I0 minus. Okay, this is asking I just before opening the switch and just after opening the switch. Okay, so you can see here, this is shorted, that means it will create short here. Okay, so this current will be what? 0. Whole current will pass through this one. Okay, so this IL0 minus, this will be IL0 minus. Okay, is it okay? So now see, if I want to calculate I0 minus, you can see here, if this current is 0, this current will be same as this current. Why? If you write a KCL here, this will be 0, this will be some amount of current, this will be what? I0 minus, this is incoming current and this is outgoing current. What will happen? These two currents will be equal, and this current you can get very easily. This is shorted, you just remove this one, this 20 ohm is removed. If you remove this one, what will happen? 20 and 20 will be in parallel, that is equal to how much? That is 10. 10 plus 20, that is equal to how much? 30. So this current will be equal to 30 divided by what? 30, that is equal to 1 ampere, and this current will be same as IL0 minus, because this current is 0. So, and this current is also equal to what? I0 minus, that is equal to 20 ohm. So I0 minus is equal to 1 ampere. Is it okay? And IL0 minus and IL0 plus is always equal to 1 ampere. Hence, now draw the circuit at t is equal to 0 plus. Step number 2. If you draw the circuit at t is equal to 0 plus 2, this switch is what? It is getting open. Switch is open. L is removed with a current source. Value is how much? That is equal to how much? That is 1 ampere. That is 1 ampere. And this inductor will be open circuited. If you draw the circuit, it will look like this one. Is it okay? This one is VL0 plus, this is 1 ampere. It is asking about this current. Can you solve this one? You can see this 1 ampere will flow also here, 1 ampere. Is it okay? This current I have assumed I1, this will be I1, then this will be also I1, because this is open circuit, there will be no current. Is it okay? Now can I write a nodal here? At this point, what we will write? VA bracket self resistance. Self means 20 and 20, these are in series. That means how much? This is 20 plus 20, this is 40. And next one is what? This is this resistance, that is equal to 20. 1 by 20 plus 1 by 40 is equal to, what is this one? This voltage positive is connected here, so 30 by this resistance is 20, 30 by 20. This is outgoing current from this node, that means it is minus 1. So VA, if you calculate VA value, come out to be 20 by 3. It is asking about I0 plus. So I0 plus, you can directly write what will be the value. 30 minus VA divided by 20. 30 minus VA divided by 20. If you calculate, you will get 7 by 6 ampere. Or you can do by different approach. You just find this current I1. I1 will be equal to VA divided by 20 plus 20. That is equal to how much? VA divided by 40, and VA is already known, 20 by 3, that is 1 by 6 ampere. This current is how much? 1 by 6 ampere. This current is 1 ampere. This is I1. Write KCL here. If you write KCL here, this is incoming current minus I1 minus 1. This is outgoing plus I0 plus. So I0 plus will be how much? I1 plus 1. 1 by 6 plus 1, that is equal to 7 by 6 ampere. So option C is correct. So what we are observing here, every problem can be solved by using the 4-step. First find the initial values, then after draw the circuit T is equal to 0 plus, then apply KVL, KCL, nodal, you will get your answer. Okay, in the next problem, what is it is asking, the circuit shown in figure was at a steady state for T less than 0 with the switch at position A. The switch is thrown to position B at T is equal to 0. The voltage V across 10 ohm, the voltage V across 10 ohm at time T is equal to 0 plus will be. Okay, so what is the switching action? Just before T is equal to 0, the switch is what? Closed. Just after T is equal to 0, switch is what? Getting open. So first we will find the initial values. So at T is equal to 0 minus, L will be shorted and capacitor will be open circuited. So L is shorted and capacitor will be open circuited, and switch will be what? In closed condition. So switch is closed. This is 16, this is 2, this is 10. This will be shorted, this will be shorted. This will give the IL0 minus current, and IL0 minus current you can get very easily. That is, this is 6 volt and 6 volt will be here, 6 volt will be here. So 6 divided by 2, that is equal to how much? 3 ampere. And IL0 minus and IL0 plus current will always remain what? That always remain what? Same. Is it okay? Now moving to the next step 2, draw the circuit at T is equal to 0 plus condition. L will be replaced with what? L is open circuited and replaced with what? A current source. C is short circuited, replaced with what? A voltage source. So if you draw the circuit at T is equal to 0 plus, what you will get? T is equal to 0 plus, what you will get? You will get at T is equal to 0 plus condition. This is the circuit at T is equal to, switch will be in open condition. This is replaced with the current source. How much current you have got? 3 ampere. This is VL0 plus. Now it is asking about V0 plus. You can see this 3 ampere will flow in this direction. There will be no current in this. Why? Because it is open. So 3 ampere will be there. 3 ampere will be there, and it is a resistance. In resistance, energy is always dissipated. So current will pass through at positive terminal and leave at what? Negative terminal. This will positive, this will negative. So V0 plus voltage will be minus of 3 into what? 10. That is equal to what? Minus 30 volt. Is it okay? So this is the problem number 6, what we have done. Now moving to the next problem. What is the next problem? That is 7th one. It is saying that in the circuit shown, switch S2 has been closed for a long time. At time T is equal to 0, switch S1 is closed. S2 has been closed for a long time. At T is equal to 0, switch S1 is closed. And at T is equal to 0 plus, the rate of change of current through the inductor in amperes per second is how much? Okay. So again we will do the same aspect. T is equal to 0 plus condition is asking. So step 1, T is equal to 0 minus, L will be short circuited, C will be what? Open circuited. If we draw the circuit at T is equal to 0 minus, what is happening? S1 is open and S2 is closed. So S2 is closed, S1 is open, L will be short circuited, L is short circuited. IL0 minus value will be, this current will be 0. So this current IL0 minus will be this current, that is equal to 3 divided by 2, that is equal to 1.5 ampere. Now we know that IL0 plus and IL0 minus will be same. So that is also equal to 1.5 ampere. Now draw the circuit at T is equal to 0 plus. L will be open circuited and replaced with the current source. What we have got, that is 1.5 ampere. C will be short circuited, replaced with the voltage source. Okay. So if you do, what will happen? The circuit will look like at T is equal to 0 plus, S1 is closed, and S2 is already closed. It is always closed. S2 is always closed. Okay, so if this one is closed now, this is replaced with the current source, that is 1.5 ampere. This is VL0 plus. Okay, so we have to calculate the rate of change of current through inductor. This rate of change of current we have to calculate. So to get the rate of change of current, what we can do, we know that VL is equal to LdI by dt, and so we have to find this VL0 plus first. Okay, you can see here this voltage VL0 plus voltage means this is this voltage VL, and this voltage we can easily calculate by applying a nodal here. You can see here, apply the nodal here. VA is VA bracket 1 by 1 plus 1 by 2. Is it okay? Bracket close is equal to, this terminal is connected to positive here, so 3 by 1. This terminal is also connected to positive here, so 3 by 2. Next, this current is outgoing, so taking it what? Minus 1.5. So VA, if you calculate, you will get 2 volt. Now you can see VA is exactly same as VL0 plus. So VL0 plus will also be equal to how much? 2 volt, and VL0 plus will be LdIL0 plus divided by dt. So DIL0 plus by dt is equal to 2 by L, and L value is how much? That is 1. So rate of change of inductor current will be at t is equal to 0 plus will be 2 ampere per second. Is it okay? So the problems will always be easy if you follow the steps what I have told to follow. Now the next problem is what? That is the 8th one. In the circuit shown below, the switch is moved from position A to position B at t is equal to 0. The current I through the inductor satisfy the following conditions. It is given that IL0 minus is given as minus 8 ampere. Rate of change of current at t is equal to 0 plus condition, that is 3 ampere per second. IL infinite has been given to us 4 ampere. It is asking about the value of R will be. See the diagram. So don't think about what have to find. Something has been given to us at t is equal to 0 plus. That means we have to solve the numerical on the basis of t is equal to 0 plus condition. So first, applying step 1, at t is equal to 0 minus, L will be shorted, C will be open circuited. Just draw the diagram, and at t is equal to 0 minus, switch is at what? At position 1. Okay, at t is equal to t greater than 0, switch is getting at position B. So drawing the circuit at t is equal to 0 minus, what I will get? Switch will be at position 1, L will be shorted, this is E1, this is what? 3 ohm, this is R, this is E2. You can see I0 minus is already given to us, that is equal to minus 8 ampere. Just apply 1 KVL here. Apply 1 KVL here. This will be minus 8 ampere, this will be minus 8 ampere. There will be no current in this circuit. So apply KVL here. What you will get? Plus 2 minus drop, minus E1, plus 2 minus what? Minus into this current multiplied by this, minus 8 into 3, that is E1 you will get, that is equal to 24 volt. And we know that I0 minus and I0 plus will be what? Same, that is equal to minus 8 ampere. Now draw the circuit at t is equal to 0 plus condition. What I will get? L will be replaced with the open circuit with the current source, and C will be replaced with the short circuit and a voltage source. So at t is equal to 0 plus, switch is moved to at position B. So switch is moved to position B. A section has been, this section will be removed. So this will be replaced. Inductor, here the inductor has been replaced with the current source. That is how much we have got, that is minus 8 ampere. Okay, so this will be VL0 plus. Okay, this is the circuit what you have obtained. Now apply 1 again KVL here. What you will get? Plus 2 minus, minus VL0 plus, plus 2 minus E2. Next, this will be plus 2 minus what? Minus what? This current multiplied by this resistance, minus 8 into R, that is equal to how much? That is equal to 0. So from this we can see here VL0 plus can be written as LdI0 plus divided by dt. So LdI by 0 by dt minus E2 plus 8R, and di0 by dt has been given to us, that is equal to 3 ampere per second. So put the values here. You will get one relation, 8R is equal to E2 plus 6. And last equation is what? It is also mentioned here, at t is equal to infinite, the IL current has been given to us. So draw the circuit at t is equal to infinite. At t is equal to infinite, L will be again short circuited, and switch is at position B. it has been shorted, switch is position B, apply KVL again, you will get minus E2 minus R into IL infinite is equal to 0. So minus E2 is equal to I infinite into R, and I infinite has been given to us, that is equal to 4. So E2 you will get minus 4R. Now see, put this E2 value here, put this E2 value here, you will get 8R minus 4R plus 6. Minus 4R is coming this side, so 8R plus 4R, that is equal to 12R. 12R is equal to 6, so R is equal to 6 by 12, that is equal to 1 by 2. Is it okay? You can see here, what I have done. 8R is equal to minus R, 4R plus 6, that is equal to R is equal to 6 by 12, that is equal to 1 by 2, that is equal to 0.5 ohm. So resistance value how much? That is equal to 0.5 ohm. Hence option A is what? Correct. Okay. So moving to the next problem, that is the ninth one. If the switch S in the circuit shown below is opened at t is equal to 0, what are the following values of V0 plus and dV0 plus by dt? Okay, so it's again the problem based on the t is equal to 0 plus circuit. So first step is what? T is equal to 0 minus. L will be short circuited, C will be open circuited. Okay, what is happening? Switch is at what position? Switch is closed at t is equal to 0 minus, switch is closed. This is 1 ampere, this is 100 ohm, this will be shorted. You can see as soon as this switch has been closed, the whole current will flow through this circuit. There will be no current here and no current will be here. So IL0 minus will be what? That is equal to 0 ampere, and IL0 plus will be same as what? 0 ampere. Okay, because IL0 plus and IL0 minus will always be same. Now draw the circuit at t is equal to 0 plus. What will happen? L is open circuited, C is short circuited, L is replaced with the current source with open circuit, and C is replaced with the voltage source with short circuit. Okay, so what will happen? The circuit will look like, switch is now open, this is 1 ampere, this is 100 ohm. This will what happen? We replace this inductor with the current source. What a value? 0 ampere. 0 ampere means that is open circuit. This will be VL0 plus. Is it okay? This is 0 ampere. Now see, it is asking about rate of change of V0 plus value. First it is asking about V0 plus value. You can see here, this is V0 plus, this node voltage. You can see here, this voltage will be same as the V0 plus voltage, and we can see here, this is open, this means whole 1 ampere current will pass here. So V0 plus will be 100 into 1, that is equal to how much? 100 volt. Okay, now it is asking about dV0 plus divided by dt, that means rate of change of this node voltage V. How we can calculate? Just apply 1 KCL here. If you apply KCL here, what is happening? This is incoming current, minus 1, so I have written here minus 1. Okay, this is outgoing current. Outgoing means that is this voltage divided by what? 100 ohm. This voltage divided by 100 ohm. I'm not taking it 1 ampere. Why I'm not taking? Because I have to calculate dV by dt. Okay, so I'm taking this current in the form of what? In terms of what? This voltage. This 1 ampere can be written as, this 1 ampere can be written as V0 plus divided by what? 100. So this is outgoing, this is incoming, so minus 1 incoming, outgoing means plus V0 plus divided by 100. Next, this current is 0. I know this current is 0, you can write it 0 here, but I just don't want to take it as the current form. I'm taking it in the form of voltage. So this current, inductor current, this is the inductor current. So this inductor current can be written in the form of voltage equation, that is equal to 1 by L integration of VL0 plus dt. Is it okay? Now differentiate the whole expression. If you differentiate the whole expression, what you will get? 1 by 100 dV0 by dt. This will be 0. This is 1 by L into VL0 plus is equal to what? 0. And VL0 plus this voltage will be same as this voltage, that is equal to 100 volt. 100 into 1, that is equal to 100 volt. So can I say that the whole equation can be written as, after differentiation, 1 by 100 dV0 by dt plus 1 by L VL0 plus, and VL0 plus is exactly same as V0 plus, that is equal to 100. So dV0 by dt is equal to this much amount of value. Okay, VL0 plus is equal to V0 plus, that is equal to 100. Multiply it here, you will get 10,000 volt per second. Hence option B is what? Correct. Is it okay? Now moving to the next problem. What is the next? In the circuit shown, the initial current I0 through the inductor is given in the figure. The initial value of the voltage across the inductor VL0 plus will be, it is again the question is what? That is at t is equal to 0 plus condition. So what will happen? First step is at t is equal to 0 minus, L is shorted, C is open circuited, but here it is already given that the initial current of the inductor I0 is equal to 1.2 ampere. It is already given in the circuit, so no need to calculate the value. Next step is what? Draw the circuit at t is equal to 0 plus. L will be open circuited, replaced with the current source. C will be short circuited, replaced with what? Voltage source. So after t is equal to 0, switch is getting closed. So I am drawing the circuit at t is equal to 0 plus. This is 10 volt, 2.5. Switch is closed. Switch is closed. This is 2.5. L is replaced with the current source. What is the direction of current? Upward. So current source direction will also be upward. That is 1.2 ampere. This will be positive. This will be negative. VL0 plus. Is it okay? It is asking about this V0 plus, and this V0 plus means this is VL0 plus, but what? This polarity is positive, this polarity is here positive. That means V0 plus can be written as minus of VL0 plus. Now can I find the value of this V0 plus? We can find. We can apply nodal here, just single nodal. What you will get? VA bracket, this resistance 1 by 2.5, this resistance 1 by 2.5. Is it okay? I'm not taking this resistance. Why I'm not taking? Because the current is already known, so no need to take that resistance. So VA 1 by 2.5 plus 1 by 2.5 bracket closed, that is equal to 10 is positive current, 10 by 2.5 plus this is incoming current, that's why plus, that is 1.2. We can calculate VA is equal to, that is equal to 6.5 volt. Now we know this voltage. Now we know this voltage, and this current you already know, that is equal to 1.2 ampere. 1.2 flow here, this will be plus minus here, this will be plus minus here, like this. Okay, now apply a KVL in this loop. What you will get? Minus to plus, V0 plus V0 plus. Next 1.2 ampere into total resistance 2.5 plus 2.5. Is it okay? Plus to minus what? Drop, that is equal to minus VA is equal to 0. VA value you know 6.5. So V0 plus value you will get how much? If you put the value of VA here 6.5, you will get how much value? V0 plus is equal to VA plus 1.2 into, that is 5, that is equal to V0 plus. If you calculate V0 plus, you will get VA plus this one, that is equal to 12.5. Hence option A is what? Correct. Is it okay? So now I have completed 10 problems. Now the 11th one is what? In this figure shown, all elements used are ideal. For time t less than 0, S1 is remained closed. S1 is sorry. This problem cannot be solved using this section. We will discuss it later when we will discuss the some exceptional cases in transient analysis. Then we will discuss this problem. Okay. So we'll discuss this problem in the later section. Moving to next problem, that is the 12th one. What is this? The switch in the circuit has been closed for a long time. It is opened at t is equal to 0. At t is equal to 0 plus, the current through 1 microfarad capacitor will be. Okay. So it is asking about current flowing through this capacitor. So to get the current flowing through this capacitor, we can do in the similar manner. First, what we will do? At t is equal to 0 minus, L will be shorted, C will be open circuited. C is open circuited. Switching condition for t is equal to 0 minus, that is it is closed. So we can calculate VC 0 minus, that is exactly equal to how much? The voltage drop across 4 ohm, and 4 ohm voltage drop will be 5 into 4 divided by 5, that is equal to how much? That is equal to 4 volt. That is equal to 4 volt. Is it okay? So VC 0 minus is equal to 4 volt, and we know that in case of capacitor VC 0 minus will be same as VC 0 plus. Next step is what? Drawing the circuit at t is equal to 0 plus, L will be open circuited and C will be short circuited with replaced with its voltage source equivalent, that is equal to, this will be 4 volt, capacitor is placed, Switch is now open circuited. Now we have to find the capacitor current. This capacitor current, this is the capacitor section. This section is what? Capacitor section. This current will be same as what the current flowing in the 4 ohm resistance, and we can get this current very easily. How we can get? This is 4 volt, this is 4 ohm. This current will be how much? 4 divided by 4, that is equal to 1 ampere, and this is the same current flowing in the capacitor. So we can say that IC0 plus will be same as what? 1 ampere. So option B is what? Correct. Is it okay? Now moving to the next problem. Assume that the circuit is in the figure has reached the steady state before the time t is equal to 0. So before t is equal to 0, the circuit is in a steady state. That means in a steady state, capacitor will behave like open circuit and inductor will behave like a short circuit. When the 3 ohm resistor suddenly burned out, resulting in an open circuit, the current IT in ampere at t is equal to 0 plus will be. Okay, this is the circuit. Just see the circuit exactly. Okay, so I'm going to solve. We have to calculate this IT at what condition? At t is equal to 0 plus condition. Okay, you can see how we can solve this one. You can see at t is equal to 0 minus, at t is equal to 0 minus, step 1 is what? At t is equal to 0 minus, this capacitor will be open circuited, this capacitor will be open circuited. Is it okay? If I am doing so, how the circuit will look like? How the circuit will look like? The circuit will look like this one. At t is equal to 0 minus, the circuit will look like this one. C is open circuited, C is open here, C is open here. I'm writing this VC10 minus, I'm writing this VC20 minus. Now see the currents. In this section, current will be 0. In this section, current will be 0. Is it okay? If this current is 0, this current is 0, that means this current is also 0. Okay. Now see, the whole current flowing from this will flow in this direction. I, this is 2 ohm current, this is 3 ohm current, and this one again what? I. So the current will flow from 1 ohm to 2 ohm to 3 ohm and then finally 12 volt source. So I have to first calculate VC10 minus and VC20 minus. You can see, can you find this I current? Yes, we can. 12 divided by 1 plus 2 plus 3, that is equal to how much? That is equal to 2 ampere. Now you know this current, you know that is equal to 2 ampere. This current is also 2 ampere. Now apply 1 KVL here. Apply 1 KVL here. You will get VC1 and VC20. I'm applying KVL here. What I will write? This is minus to plus VC10 plus to minus drop I into 2. I value is 2. That is equal to 4. This current is 0. So this voltage will be 0. So what will happen? VC10 is equal to how much? That is equal to 4. Similarly, in this loop applying KVL, what will? Minus to plus VC2, this will be 0 volt, this will be how much? Plus minus 3 into I is equal to how much? 2, that is 6 volt. So VC20 minus, that is equal to 6 volt, and we know that VC10 plus is equal to VC10 minus is equal to 4 volt, and VC20 plus is equal to VC20 minus, that is equal to 6 volt. Now next step is what? Draw the circuit at t is equal to 0 plus, and it is saying that at t is equal to 0 plus, L will be replaced with an open circuit with a current source and C will be short circuit with the voltage source. But it is saying that at t is equal to 0 plus, 3 ohm is burned out. So remove from the circuit 3 ohm. If 3 ohm is removed, this will become open circuited. This current I am represented I0 plus. This will be replaced with voltage source. What is 4 volt VC1? This is how much? This is 6 volt. Now you can see the current I1, whatever current will flow from here, it will go in this direction, in this direction, and in this direction. There will be no current in this direction. There will be no current, zero current in this direction. The whole current I1 will flow in this direction, and in this direction. There will be no current in this section. And you can see this is I1. This will be also what? I1. This will be also what? I1. And this will be also what? I1. Okay, so we have to calculate this I0 plus. Now see, I0 plus current we have to found. You can see I0 plus is here. This is I0 plus. There is no current here. That means I0 plus will be here also. Okay, is it okay? So can I apply a KVL here? If you apply KVL here, what will happen? Plus to minus, minus 4 minus total drop in this what? I0 plus into 2 plus 2, that is equal to 4, that is equal to 0. So I0 plus will be how much? Minus 4 by 4, that is equal to minus 1 ampere. Is it okay? So I0 plus will be minus 1 ampere. Now the next problem, in the network shown below, it is given that V is equal to 1 volt and dV by dt is equal to minus 10 by Vs at a time t, where t is the time after S is closed. What is the value of capacitance C? Okay, so it is given that the V is given as 1 volt and dV by dt is given at minus 10 V by S at a time t. T means when the switch is getting, after which the S is closed. That means it is, again, if I am assuming t is equal to 0, that means after t is equal to 0, the V voltage, that is equal to 1 volt, and rate of change of voltage, that is given as minus 10 by Vs. And before switching, what is happening? I don't know about what is the value of V. These all values have been given for what? After switching. That means at t is equal to 0 plus condition. So we will apply the same procedure. Okay, so step 1 is what? What is the step 1? At t is equal to 0 minus, switch is what? Open circuited. If switch is open circuited, this will be open circuited, capacitor is also open circuited. What will happen? There will be no source in the network. If there is no source in the network, this voltage will become what? That is equal to 0. So VC 0 minus VC, sorry, what is asking in this problem? In the network shown below, it is given that V is equal to 1 volt and dV by dt is equal to minus 10 by Vs at a time t, where t is the time after switch S is closed. What is the value of C? Okay, so in this problem, nothing is mentioned about the initial value, but we know that this value is given after switching. That means t is equal to 0 plus. That means the initial voltage will also be how much? That is equal to 1 volt. But if you see the circuit is become source free, but this capacitor is already charged. Is it okay? Because VC 0 plus and VC minus condition will be same. So if this VC 0 plus is equal to 1 volt, that means VC 0 minus will also be the 1 volt. Don't bother about what the circuit is representing here. If someone is saying, if this circuit is here and someone is saying VC 0 minus is equal to 5 volt, then don't think about the switch is open, there is no source, and VC 0 will be what? That is equal to 0. No, it's wrong. If it is given that VC 0 minus is equal to 5 volt, then you have to take that thing. Is it okay? So drawing the circuit exactly at t is equal to 0 plus, if you draw the circuit exactly at t is equal to 0 plus, this switch will be closed. Switch is closed. This capacitor will be replaced with what? Its voltage, and capacitor will be shorted. Then what will happen? The circuit will look like at t is equal to 0 plus, it will look like 3 volt. This switch is closed. 4 ohm. This is 1. This capacitor is what? Capacitor has been what? That is replaced with its voltage equivalent. Now it is asking about C value. Okay, to get the value of C, we have to know about V and IC both. Okay, because you know that if the IC we can get it, if the value of IC we can get it, then we can easily find the value of C. Why? Because dV by dt has been given to us, and IC is equal to how much? C dV by dt. So prime objective is what? To get the value of IC 0 plus, and from this circuit we can easily get the value of IC 0 plus. How we can get this one? You can see, if this current is I2, this voltage is how much? 1 volt. This voltage will also what? 1 volt. So we can say that I2 is equal to 3 minus 1 volt divided by 4. That is equal to how much? That is equal to how much? This I2 will be how much? That is 3 minus 1 divided by 4. That is equal to 0.5 ampere. Is it okay? Okay. Now see, this voltage is 1 volt. This voltage is also 1 volt. So 1 divided by 1, this I1 current how much? That is equal to that is equal to 1 by 1, that is equal to 1 ampere. So we can apply a KCL here. If you apply KCL here, IC0 plus, you will get that is equal to minus 0.5 ampere. Is it okay? Now, as we know, IC0 plus is equal to C dV0 plus divided by dt, and IC0 plus, you know, dV by dt is already given to us. So C value you will get 5 into 10 to the power minus 2 microfarad, or 0.005 farad. Is it okay? So moving to the next problem. What is the next problem? That is 15th one. In the circuit shown in the figure, in a steady state with switch S is open, the switch is closed at t equal to 0, the values of Vc0 plus and Vc infinite will be. It's a very simple problem. Step 1, at t equal to 0 minus, L will be shorted, C will be open circuited. Just draw the circuit at t equal to 0 minus. C will be open circuited, this will be Vc0 minus. Okay, there is no L, that means neglect it. Now see, this voltage Vc0 minus you can easily get. This is open circuit voltage, this is also open circuit voltage. There will be no current here, that means this voltage will be same as this voltage. So Vc0 minus will be same as V1, and V1 is equal to, that is equal to 2 into 1, that is equal to 2 volt. Hence Vc0 minus will also be, that is equal to 2 volt. Is it okay? This is the circuit at t is equal to what? 0 minus. Now draw the circuit. Vc0 minus will be exactly same as Vc0 plus, so Vc0 plus will also be the same value, that is equal to 2 volt. Now it is asking about at infinite value. So at infinite, if we want to calculate, what will happen? Just make this circuit at t equal to infinite. Switch is what? Getting closed. Switch is closed. C will be open circuited again. The circuit will look like this one. The circuit will look like this one. This will be closed. This is open circuited. Now we have to calculate Vc infinite. You can see if it is shorted, this will be shorted also. This means there will be no current here. Okay, the whole 2 ampere current will flow through this switch. There will be no current here. We can say that this Vc infinite voltage will also be this voltage is 0. So Vc infinite voltage will also be equal to 0. Hence Vc0 minus we have got how much? 2 volt, and Vc infinite we have got what? 0 volt. Hence option A is what? Correct. Now moving to the this is, I guess, last problem. Okay, moving to the next problem. In the steady state circuit shown in figure reached with S is open, when S is closed at t equal to 0, the current I at t equal to 0 plus will be. Same manner we will do step 1. T is equal to 0 minus, C will be open, L will be shorted. Make it open, C will be open, switch is open for t is equal to 0 minus. Okay, this voltage can be obtained. This current will be 0. Why current 0? Because this is open, this is open. Vc0 minus will be same as what? This is 2 ohm. The potential drop across 2 ohm, and this will be calculated as 1 ampere will flow in this direction. So Vc0 minus will be 2 into 1, that is equal to 2 volt, and Vc0 plus Vc0 minus will be same, that is equal to 2 volt. Is it okay? Next step is what? Draw the circuit at t is equal to 0 plus. L will be open circuited, replaced with its current source. C will be short circuited, replaced with its voltage equivalent. So I am just representing switch is getting closed at t is equal to 0 plus. The capacitor will be replaced with its voltage equivalent, that is equal to 2 volt. This is 1 ohm, this is 2 ohm, this is 1 ampere. It is asking about I value. This is I value, I0 plus value. In this condition, you just apply nodal here. You can apply nodal here. At node 1, if we write nodal, what we will get? V1 bracket 1 by 2, 1 by 1 bracket close, minus V2 divided by 1 is equal to incoming current, how much? That is equal to 1. This is equation 1. And V2, we know that is equal to 2 volt. V2 is given 2 volt. So from equation 1 and equation 2, we can calculate the value of V1. And V1 we will get that is equal to 2 volt. V1 we will get that is equal to 2 volt. If we get V1, then we can say that I0 plus will be 2 divided by 2. That is equal to how much? 1 ampere. Hence option A is correct. So in this manner, we have completed the problems, especially based on t is equal to 0 plus conditions. And I think whatever the steps I have given to you, just try to follow those steps. You will never get disappointed in problem solving. Is it okay? To enhance your problem solving, make some general steps that you can apply in maximum cases, but there are some exceptions are always there in problems, so don't bother about. Maximum problems can be solved using all these steps. Okay, so in next lecture we will do the last topic from transient, that is the some special cases available in transient and what to do in those cases. We will do the Laplace transform. If we never apply all these things, we can apply the Laplace domain approach, because Laplace domain approach in transient analysis is known as universal approach that can be applied in every type of problems, whether it is first order, second order, third order, fourth order, or fifth order, whatever the order of the circuit is, the Laplace domain can be applied everywhere. Is it okay? So for any doubts, just join our Facebook group, that is no problem GATE-ESE, and like us and share this video to others so that everyone gets benefits from all these videos and make things happen in a very easy manner. Okay, so thank you very much.